You know, it's interesting. You don't often hear developers talk about loving a language, not really loving it.
No, you hear respect, maybe appreciation.
Exactly. But there's this one, Rust, that keeps showing up in surveys as, like, most loved.
It does, consistently.
Yeah.
And it's not just hype. We've been looking at some analysis, let's call it Rise of Rust.
Right.
And it really shows how it's become, well, pretty significant in software development today.
So that's what we want to do in this deep dive, right? Get past the buzzwords.
hmm
Understand why developers feel this way, what actually makes Rust different.
Yeah, figure out what the core appeal is.
Think of this as, your shortcut to understanding a really important trend happening right now.
And it's more than just knowing another language, I think.
Mm-hmm.
Understanding Rust, it tells you something about where software development is heading.
How so?
Well, this focus on safety and performance together, plus, making the developer experience good, that seems key now.
Okay, safety and performance. Let's start there. The big thing everyone mentions is memory safety without a garbage collector. Now, for folks not deep in code daily, why is that specific combo such a big deal?
Sure. So traditionally, you had languages like C or C++ get. You manage memory yourself, totally manual.
Which gives you control, but
But it's easy to make mistakes.
yeah.
Access memory you shouldn't, forget to clean things up, leads to crashes, security holes, all that bad stuff.
Okay.
Then on the other side, you've got languages like Java, Python. These are garbage collector.
Right, that cleans up memory automatically.
It does, which is simpler in some ways. But that garbage collector has to run sometimes. And when it does, your program might pause for a bit.
Ah, those little freezes or stutters you sometimes see.
Exactly.
Mm.
Performance isn't always predictable. So Rust comes along with this completely different idea, the ownership model.
Ownership, okay.
It's basically a set of rules about how data is handled.
Yeah.
And the key thing is the Rust compiler enforces these rules before you even run the program at compile time.
So it checks everything up front, like a really strict proofreader for memory.
That's a great way to put it, yeah. It makes sure memory is managed safely and efficiently, but without needing that runtime garbage collector.
How does ownership actually work then?
Well, the basic idea is that every piece of data has one and only one owner.
Okay.
When that owner goes away, like a function finishes this, the memory is automatically cleaned up instantly. No waiting for a garbage collector.
And there are rules about borrowing data too.
Exactly. You can lend out access or borrow data, but under very strict conditions that prevent problems like two parts of the code trying to change the same thing at once unsafely.
Okay, this is the really crucial part then. By checking all this before the code runs,
Mm-hmm.
Rust just eliminates whole categories of bugs. Like, they can't even happen.
That's the promise and largely the reality. Things like null pointer dereferences using memory after it's freed, data races, and concurrent code the compiler catches them. So you spend way less time debugging those horrible, hard-to-find memory issues. Fewer crashes, more stable software. It's a huge win.
Huge win for developers, but also for anyone using the software. Less crashing is always good.
Definitely.
Okay, so that's safety. The other side is performance. The analysis says Rust performs comparable to C and C++.
Yeah.
That's really fast.
That's the gold standard for speed, pretty much.
Yeah.
Rust is a compiled language,
Meaning,
meaning it gets translated directly into the raw instructions. The computer's processor understands machine code, and it's heavily optimized during that process.
no intermediate layer, no virtual machine like Java.
Nope. Direct to metal, essentially. That's why it can hit speeds very close to C and C++.
So you get the safety and the raw speed. That feels like the holy grail almost.
It's a very compelling combination, yeah.
Yeah.
It makes Rust fantastic for things like system programming, game engines, anything where performance is absolutely critical.
And because there's no garbage collector causing unpredictable pauses.
Right. Its runtime behavior is more deterministic. You know what to expect. That's vital for what you call latency-critical applications.
Like real-time systems, financial trading.
Exactly.
Yeah.
Places where even tiny millisecond delays matter a lot. Rust is really good there.
Okay, that makes sense. Let's shift gears a bit. Concurrency. Running multiple things at once. Always tricky.
Notoriously difficult, yeah.
But the analysis talks about fearless concurrency in Rust. How does it manage that?
Well, it actually comes back to that ownership model again.
Ah, okay.
The same rules that ensure memory safety also apply to sharing data between different threads, different concurrent tasks.
So it controls how data is accessed when multiple things are happening.
Precisely. The compiler checks, again at compile time, for data races.
What are those exactly?
That's when multiple threads try to access and maybe change the same piece of data simultaneously without proper coordination. It leads to chaos, unpredictable results, bugs that are incredibly hard to track down.
And Rust's compiler just stops you from writing code like that.
It does. It won't compile if there's a potential data race, according to its rules. So you can write multi-threaded code, use async programming, pass messages between tasks.
With much more confidence, without constantly worrying about those race condition bugs.
Exactly. Fearless concurrency. It removes a whole class of really nasty runtime bugs right from the start.
Is there a downside to that strictness, though? Does it make it harder to write initially?
That's a fair point. Yes, especially if you're coming from a language that's less strict at compile time. You might find yourself fighting the compiler initially.
The borrow checker, right. I've heard developers mention that.
That's the one. But once you understand the rules, developers generally find the payoff, the runtime safety, and the confidence it gives you is absolutely worth that initial learning effort.
Okay, makes sense. Trade-off for robustness. Now, tools. Good tooling can make or break a developer's experience. The analysis highlights Rust's developer-friendly tooling. What stands out?
Oh, the tooling is fantastic. Really top-notch. First off, you've got Cargo.
Heard that one? Build system and package manager?
Yeah. It makes managing dependencies, other libraries your project uses super simple. Adding libraries, compiling your project, running tests, it's all handled smoothly by Cargo. Takes away a lot of the usual setup headaches.
Nice. Less boilerplate.
Definitely. Then there's Clippy. It's like a built-in code reviewer.
A linter.
Yeah, a very smart linter. Catches common mistakes, suggests better ways to write things, helps enforce the style, makes your code better. More idiomatic Rust.
Helpful. What else?
Rust FMT automatically formats your code. So everyone on the team has code that looks the same. No more arguments about brace style.
Always a plus in team settings.
And documentation generation is built in. You write comments in a specific way, and it generates really nice, browsable documentation for your code automatically.
So it sounds like a whole ecosystem designed to make development smoother, more efficient, and just nicer.
That's exactly it. The language itself is powerful, but these tools make working with it day-to-day genuinely enjoyable and productive.
And a happy developer is often a productive developer. Okay, one more. Why? The community. The analysis mentions a strong and supportive community. How important is that?
Oh, it's crucial, especially for a language with a reputation for being a bit challenging to learn initially.
Like Rust.
Like Rust, yeah. A good community provides learning resources, answers questions, helps you when you get stuck, and the Rust community is widely known for being really welcoming and helpful.
Where do people gather? Forums? Chat?
Yep, official forums, Discord channels, Reddit, lots of places. People share knowledge, help debug problems. There's even a mentorship program, which is great for newcomers. Plus, the official documentation is excellent.
So that support structure really helps people get over that initial learning hump.
Absolutely. It makes a huge difference in lowering the barrier to entry.
Okay, last part in this section. Design for modern development. What does that mean in practice? What modern challenges does Rust tackle well?
Well, it wasn't designed in a vacuum decades ago. It was created relatively recently with modern problems in mind. Things like WebAssembly for running high-performance code in browsers. Rust is a star player there.
Okay.
Embedded systems. Think IoT devices, firmware. Its safety and low-level control without overhead are perfect.
Makes sense for resource-constrained devices.
And cloud-native applications. Stuff that needs to be scalable, secure, efficient, with resources in massive data centers. Rust fits really well there, too.
And big companies are noticing.
For sure. You see Microsoft, Amazon, Google, Mozilla, many others, not just experimenting, but using Rust for significant projects. That's a pretty strong signal about its relevance for the future.
Definitely a strong vote of confidence. Okay, so we've got a clear picture of why Rust is so loved. Let's talk about where it's actually being used. The analysis breaks it down. Web development first, that seems slightly less obvious.
Yeah, it's not the first thing you think of. Maybe not for like flashy front-end stuff, but for the back end. Absolutely.
The server-side logic.
Exactly. Frameworks like ActixWeb and Rocket let you build web servers and APIs in Rust. And because Rust is so fast and handles concurrency so well.
It can handle tons of users hitting the server at once.
Precisely. For high-traffic, high-concurrency web services, Rust is becoming a really compelling choice for the backend due to its performance and safety.
Okay, so back-end powerhouse potential. Next up, embedded systems. You mentioned this already. Seems like a natural fit.
It really is. Firmware, IoT devices, real-time systems,
Yeah.
these places need reliability. A crash isn't just inconvenient, it could be dangerous.
Right.
So Rust's memory safety guarantees, combined with its ability to run on minimal hardware without a big runtime or garbage collector, that's incredibly attractive. Companies are definitely adopting it for this.
Fewer crashes in your smart thermostat or car's control system. Good.
Very good.
Game development,
Another area where...
where speed is king.
Yep. Games push hardware to the limit. You need speed, but also security to prevent cheating or exploits.
And Rust offers both.
It does. Plus, the ecosystem for game dev in Rust is growing. There are engines like Bevy and Amethyst aiming to provide experiences similar to Unity or Unreal, but built on Rust's foundation.
Interesting. So maybe more Rust-powered games in the future.
Could be. It's definitely an active area.
Blockchain and crypto also get a mention. Security is paramount there.
Absolutely critical. Projects like Solana, Polkadot, others use Rust. Why? Well, the speed is important for processing transactions quickly.
Okay.
The concurrency handling is vital for managing lots of simultaneous operations on the network.
Right.
And maybe most importantly, the strong focus on correctness and safety helps prevent bugs that could lead to catastrophic financial losses in that space.
Yeah, you really don't want memory errors and code handling millions of dollars.
You really, really don't. Rust's compile time checks provide a lot of confidence there.
Finally, operating systems and systems programming. Back to the fundamentals.
Yeah, this is traditionally the domain of C and C++. But Rust is making serious inroads.
Like entire operating systems.
Yep. Redux OS is a prominent example written largely in Rust. And maybe even more telling, you have companies like Microsoft experimenting with rewriting parts of Windows in Rust.
Parts of Windows, what?
Primarily for security and stability. Replacing C++ code, which is prone to memory safety issues, with Rust could make the whole system more robust. That's a huge endorsement.
Wow, that really speaks volumes. Okay, but let's keep it balanced. Nothing's perfect.
Huh?
The analysis does talk about the challenges of learning Rust.
Yeah.
What are the main hurdles?
The learning curve is probably the biggest one people talk about. It is different.
Especially coming from Python or JavaScript.
Exactly. Those languages are more dynamic, more forgiving in some ways. Rust's compiler is strict. Very strict.
About ownership and borrowing.
Yeah, getting your head around the ownership model, lifetimes, the borrow checker, it takes time. It forces you to think about memory management more explicitly than you might be used to.
So it demands a deeper understanding up front.
It does. But like we said, the payoff is there.
Yeah.
Once it clicks, developers often say they write better, safer code because of those constraints, not despite them. They appreciate the guarantees.
So an initial investment for long-term gain.
That's the idea. The other challenge mentioned is the ecosystem maturity.
Meaning libraries and tools.
Right. While it's growing incredibly fast, it's just not as fast as, say, Java's or Python's ecosystems, which have been around for decades.
So you might not find a ready-made library for every single niche thing.
Sometimes, yeah. Or a particular library might be newer, less battle-tested, maybe have less documentation than its equivalent in an older language.
Yeah.
But this is improving really rapidly. The community is very active in building things out.
So it's getting better all the time, but maybe not quite as comprehensive yet.
It's a fair summary.
Which brings us to the big question posed. Is Rust the future of programming? What do you think? Is that too strong a statement?
Well, the future is probably too strong for any single language. Technology moves fast. But is Rust going to be a major part of the future? I think all the signs point to yes. Based on its continuous growth, its adoption in really diverse and important industries, and the fact that it solves fundamental problems, safety and speed, that aren't going away. If anything, those needs are becoming more critical.
That blend seems key.
It really is the unique selling point. As more companies feel the pain of security breaches or performance bottlenecks, Rust just looks more and more attractive. Its usage is almost certainly going to keep growing.
So for anyone listening, getting familiar with Rust seems like a smart career move.
I'd say so, yeah. Whether you're doing web stuff, embedded games, systems, understanding Rust and its principles gives you a valuable perspective and a powerful tool. It's becoming increasingly relevant across the board.
Okay, let's try and wrap this up with some final thoughts. The overall picture from the analysis seems to be Rust as, well, kind of revolutionary.
I think that's fair. Its approach to combining performance with compile time safety is genuinely innovative. Add the great tooling and the vibrant community, it has huge potential.
The learning curve is real, though.
It is, no doubt. It requires effort. But the rewards in terms of code stability, easier concurrency, and raw performance are significant long-term benefits.
And as software complexity grows and security threats increase,
Exactly. The need for scalable, reliable, secure solutions just keeps going up. Rust is really well positioned to meet those needs.
so it's not just a trend, maybe, more like a shift in priorities.
I think so.
Yeah.
It represents a move towards valuing safety and performance more intrinsically, building it into the language itself.
Yeah.
That philosophy seems to align really well with where the industry is heading.
Definitely a language to watch, or maybe even pick up.
Absolutely worth serious consideration.
So here's a final thought for you listening. What does the rise of a language like Rust, one so focused on getting both safety and performance right, tell you about where software is going? What priorities are really driving innovation now? Maybe dig around, see what Rust projects are happening in fields that interest you. You might be surprised what you find.